Hello and welcome to Drone Operations in 2020. My name is Katie Gilmore. I will be walking you through drone operations today. I am a longtime aviator. I've been in aviation since I was a kid. I grew up flying airplanes with my grandpa and got into the drone world about 5 years ago. I used to have my own small company, and now I work for MNDoT. This is my third year doing this workshop, and it's always a lot of fun, great questions. And unfortunately, I don't get to see everybody's face this year. So please, if you have any questions, certainly send me an email. My email address is there on that slide. It's also on the last slide. I'd be happy to chat with you if any questions or follow-up, and we'll get. So a bit about what we'll be talking about today. First, we'll go over a bit of the technology, some applications for the drone aircraft and post-processing. Then we'll talk about flight planning, some tips and tricks there, a bit about the rules, because we can't let those pass by, and then we'll talk about post-processing at the end. So I always start with some background on drones. Some people are surprised to hear that drones have been around for more than a century. Nikola Tesla first piloted remote control boats back in 1898, and then by the 30s they were doing competitions with hobbyist aircraft, remote control aircraft. Of course, the military can't pass up good technology, so they were flying drones about the same time. They first flew them in World War I, they were successful in World War II, and then of course the word drone kind of came into our lexicon back in the early 2000s in Afghanistan and Iraq with the drone strikes. But now we've kind of hijacked that word drone and brought it over into our commercial. So between today and back when Tesla started, there's been a century of this. So this is a friend in North Dakota. I went to college up there, flying RC aircraft at the back of a truck. There were not so many rules back then, but we've been doing this for decades, for a century. But then this happened, and this is a DJI Phantom. You've probably seen the newer versions of these out flying around. In 2016, the FAA created a certificate or a pilot's license to fly drones, and since that happened about 3.5 years ago, we now have more than 176,000 remote pilots certified. That's a good way to think about that. Manned aviation has been around for, again, a century for that license, and look at that trend. So remote pilots on the bottom climbing up to the private pilots. This is Minnesota only, but you can see that it's ready to intersect. So in perhaps, when the 4-year mark hits, we'll have possibly the same number of private pilots and remote pilots. So this is a huge growth in the aviation industry, which is really exciting. This technology is fascinating and does all kinds of great things. So let's talk a bit about it. Who are these pilots? Who are the folks that are making up those 3,500 pilots in Minnesota? And the neat thing is it really ranges. There's a diverse background of the pilots that are out there. Some are GIS professionals, folks who have been in the survey world or photogrammetrists, worked in ArcMap, Esri, Fiends, have a background in this. There are some like myself who were manned aircraft pilots previously, or professional pilots like airline pilots that have transferred over to this. And then there are a significant number of people who this is their second career. Maybe they're web designers, or they were in advertising or finance, or IT, and they've transitioned into drones. And that's really interesting because it gives our career field a really nice, diverse pool of input, and that really leads to some really interesting creativity. As far as pilot training goes, it's interesting. Manned aircraft pilot training is pretty rigid. There's a syllabus, and you have to take a flight test as part of your certificate. With drones, you don't have to, so you can get your training from anywhere. You can be a manned aircraft pilot and transition over into this. You can be professionally trained, and by that I mean paying for a course to get your knowledge and flight skills to get your certificate, or self-taught. And a large number of folks now are self-taught, either on YouTube, trial and error, through message boards or Facebook, all kinds of great ways to get information on how to fly and when the rules go. And of course, once you know what you're doing, then it's time to move on to the hardware. So COTS is commercial off the shelf. There are a number of hardware options out there Right now, the market is really dominated by a company called DJI, and so you'll see that a lot on this page here. And when you're looking at aircraft, it's great to talk with other folks in your industry or in your area and find out what kind of aircraft they are flying. A lot of it is based on application. Safety is very important, and then the payload that it can carry. We'll talk about sensors next, but you'll see each of these drones has a different type of, different type of camera, and what you can carry on there and what's swappable and what's not is really important based on what your application. So for example, not all of these sensors are swappable. The Phantom 4, which is the white squarish one that you see a lot, is not swappable, but it's got a great shutter. On the other hand, the Inspire, the Matrice series, those can all be interchanged. So you can go from thermal to near infrared to RGB, whatever you need for your application. But not all cameras are created equal. So the camera on your Inspire might not be as ideal as the camera on your Phantom, which is quite a bit cheaper. Shutter speed is really important if you're going to be mapping with thermal. The speed of that shutter is really slow, and so how you're going to map with a thermal camera is very different than how you're going to map with red, green, blue. Mechanical versus electric shutters are important. It affects the role of your photos. Pix4D and some of the other software kind of corrects for that, but it's just another variable added to your model. So those are all important considerations for the aircraft that you have. There are also a number of custom hardware options. It's definitely worth a look. So these are two large aircraft that I've flown, all 100% custom, but for very specific applications. So depending on what you're doing, it's worth talking to the industry and folks to figure out what makes the most sense for you. And then, of course, once you get your hardware, it's not worth anything unless you've got some software on the back end. So whether it's your flight application, which we'll talk about shortly here, or it's the post-processing software, it's important to understand what the options are, what may or may not work for your company. We'll talk about a couple of these here as we go through this presentation today, but there are a number of options out there for software. And then what are you going to do with it? So once you've got the hardware and the software, you're going to go out in the field, and what's your plan? So there are the sky's the limit for your industry uses. Everything from mapping to inspection, just plain old, they use the low-hanging fruit documentation, photography and videography, often to the miscellaneous things like emergency services, agriculture, multispectral, etc. The products that you can get from these drones really range quite a bit. So everything from JPEG to movies, photo stitches, orthomosaics, into your 2D and 3D models. The uses are quite vast. It's really, really interesting. And again, this is where the diversity comes in, is people from these different career fields see these products and think, oh my gosh, I know a problem that this could solve. And there's lots of opportunity to use drones. So I'm going to go through a couple of pictures. Not all of these are mapping, modeling related, but they're all things you may need to do with your drone, whether no matter what your work is. So the first, the kind of low-hanging fruit, photography and videography. So these are some video uses, things like traffic monitoring, intersection evaluation, flooding, of course, is a big one for us, hazards, documentation, right-of-way is a big one with video. All great uses for drones and a great way for you to get some as well. This is just some documentation of roadways that will be under construction. And it's a great way to show your community of what the area looks like, and also get a site view for your project managers. Here's an example of a traffic study. And so maps are great, but being able to view these things in real time gives you a really interesting look at how things are moving, what size vehicles there are, where the pedestrians are crossing, where they're hopping out of the cars on a cold day to get across the schoolyard as fast as possible. So really, really great information that then can be used in your 2D models. And then public engagement. So this is the new bridge up in MNDoT going to Canada. Just took some quick video at the end of the season as they were wrapping up here. A great way to get a view of the site and also show the community the progress that's been made. And then another way to use your drone to take some video. I can't resist that audio track, huh? And then we'll get into the 2D and 3D models here. So things like stockpiles, contouring, site layout, staging, inspections, maps, etc. All great uses for drones. So we'll go through a couple of examples here. So this is one in particular. This is a dam that we mapped out, and you can see on the right side this red area is our area of interest, and then we've got some ground control points here that were marked by surveyors. You can see them in the actual photo here, the white X. We take a bunch of pictures, and to say it crudely, we stitch it together. This comes out geo-referenced, and you get a 2D TIFF, and you can get 3D model as well, LAS files, OBJs. So here are some examples. We've got our 2D orthomosaic on the left and our DSM on the right. I always point out the dark peanut type shape on the top of the orthomosaic, and that's interesting. Is it fresh dirt? Is it a hole? Is it a hill? And you can look on the right at the DSM and see exactly where that is. So super simple. One of the most basic things we can do with the drones. Easy to fly, easy to process, and now I know where my water might pool or runoff might occur. Where do I need to put up my erosion control, etc. So a great way to get information about. This is the one I always like to show. This was actually one of our first models we ran years ago. The fuzzy part on the bottom is the base layer from ArcMap, and the beautiful high-resolution photo on the top is actually an orthomosaic with 2 centimeter resolution. So you can see the detail that we can see in these photos. Of course, you can zoom way in. This is about a little over a gig for this 3/4 of a mile TIFF, and it's just spectacular resolution for, you can use these for right-of-way monitoring, construction monitoring, project management, etc. All kinds of fantastic uses. Here's another one. This is just 2 orthomosaics overlaid, and you can see this one was an intersection reconfiguration, so they changed, you can see the lighter one on the background and then the new intersection on the top. It's a great way to show the community what's been done, and then also manage and update your information on the back. Another great thing about these products, a lot of this software allows users to output to many different ways. So it's no longer just you have to have AutoCAD or ArcMap or QGIS to open these files. They can now be exported onto Google Earth, Google Maps, etc. Lots of uses for people who are outside of the typical GIS. Getting into the 3D models, so things like volumetrics are common with also 3D models of buildings. And then this is one I like to show. This was a MNDoT project. We needed to get some information about the rocks under that tunnel. They want to just monitor them over time. It takes a bit. That's a pretty steep drop off from the edge of those trees down to the bottom where the river is. So just dropped the drone in, and we took some video. You can see all the rocks here. They just want to monitor that over time and see what it's going to look like. So we did a video, and then we took a couple hundred pictures, and we were able to turn it into this 3D model. So now with this model, we can compare over time. We can compare the point clouds over time, see if volumes are changing. changes in the structures. And then also we have, this is the model, and then this was the high resolution images that go with it. And we can look to see if these pieces of rock are shifting, if anything's changing over time. These can also be exported into as LAS files or OBJs, PLYs, all kinds of different 3D models that you can then pull into ArcScene or AutoCAD. So lots and lots of uses. This one is one of the tunnels up north. Again, we were looking at measuring volumes with this. This is actually a 3D point cloud. So again, something you can model or measure off of, compare point clouds over time for volume changes, etc. So lots of great uses for this strategy. And there's just an example of some cut and fill measurements in some areas of interest. Getting off into multispectral analysis, so lots and lots of different uses for in multispectral. So everything from flooding, plant health, tree degradation. We've been using multispectral for a long time, but the high resolution that the drones can give you a much a lot more data to work with. Things that are a lot more sensitive. Agriculture has been a huge industry for the multispectral drone aircraft, so lots to talk about there. Something that I'm really interested in. So if you have any questions, let me know. Here's some examples of multispectral. So this is a lake, red, green, blue versus the thermal. So you can see where the water edge is really well with the thermal camera. And then on the right, we're looking at RGB and then used near infrared to get to one of the moisture indices. And and you can see for instance, in these areas on the top of the screen where it looks like dry, and there's quite a bit of moisture there. So again, it's an indication. It gives you an idea of where to look for additional moisture on the ground. All right, so we have got all those uses. So now let's make a map. The very basics here, you have to get a number of overlapping photos, and these photos overlap by left to right, as you can see here by the shaded area, and I'm sorry, front to back this way, and left to right. So we take dozens, hundreds, whatever it takes of these photos overlapping, and we do a lot of math. But meaning the computer software does a lot of math based on pixel color, pixel geometry, georeferencing, and essentially smooshes them all together to create a model. So the 60 to 70% and 25 to 40 you can ignore. That's for a manned aircraft. We do a lot higher overlap for our aircraft. But that's basically it. You get a bunch of photos, you smush them all together, and you end up with it's mostly that easy. One thing to remember is that this is all calculations. My background is actually weather, and I worked in weather modeling for a little while. And so we got well acquainted with the fact that the weather model is a guess based on a number of math equations and some assumptions. These models are very good, the photogrammetry products that come out of these, but it's still an equation that gets us there. There's some known errors, there's some known difficulties. For example, if you're working with mixed clouds and sun or deep shadows, you can create some abnormalities in your model. It depends a bit on scale, a bit on the environment, quite a bit on the sensor in the aircraft. But even with all these caveats, it's pretty good. This information that we can get out of these models is good. So everybody wants to know, can I get down to a 10th? Am I going to replace my surveyors with all these? And the answer is probably not. There's a lot that goes into them. So when we talk about accuracy, we talk about relative versus absolute. So relative accuracy is the accuracy within your model. So if I am mapping out this intersection and I want to know if the width of the road is correct in my model, I can measure that within and get the relative accuracy. If I want to then drop that on a map and put it at the right lat long, that is then my absolute accuracy. So your absolute accuracy it's important to have surveyed control in there because of changing the coordinate systems, also the accuracy of the GPS sensor versus the accuracy that you're used to getting on aerial maps is important. So a lot that goes into that. Another thing to consider is Z is generally not great. It's usually 2 to 3 times worse than your XY. There's also some difficulties with Z in local coordinate systems. It gets a little complicated. It's not my expertise. And then there's also, of course, as I kind of mentioned, translation between the coordinate systems, going from the world coordinate system of the drones down to our local coordinate systems, our county coordinates that we usually use, require surveyed control. Resolution is another one that we always talk about that does impact your accuracy. There is a trade-off between time and resolution, and then of course resolution in your file size. So higher resolution data will take longer to gather because the drone is lower, has to fly slower, and has to have more overlap. Because it's taking more photos, then the file size is also quite a bit larger. So decide what works best for you, and then understand the cost benefit of that. One interesting point that was brought up to me is that there are assumptions about accuracy when your resolution is very high. So when we look back at that photo earlier that had the very high resolution drone map and then the ArcMap base layer, your brain tends to think that the high resolution model is very accurate, even though it may not be. So it's important to always understand the data and make sure you have the right metadata or caveats along with it. Other caveats for your accuracy can be weather. Again, we mentioned the clouds, applicable laws, so flights over people, be required to be within line of sight, etc., will affect your flight lines, and then that will impact your model accuracy. We'll talk about that a little bit more coming up. Your setup, can you lay ground control in marshy areas? Can you lay ground control on busy roads? That will affect your accuracy. Understanding your quality reports and how you validate is also really important. And then the last thing is what's on the ground. So if you have a very homogeneous area like rows of corn, anything with low contrast or that's highly reflective like water is going to have a hard time modeling. So experience does matter with these. Being a good photogrammetrist does not make you a good drone pilot, does not make you a good aero pilot. So it takes a lot of background on some of these to get to a really good product. So a lot of people ask me about GPS versus GCPs versus RTK or PPK. Which should we be using? And it really depends on what you are going to use the data for. So a traditional GPS chip in a commercial drone aircraft has a usual. I'm sorry, that's the absolute accuracy, not relative. That's a mistake. The absolute accuracy is typically 5 to 15 feet. It can vary a lot more. Again, I mentioned Z is not great. It is in world coordinate systems, but sometimes that's good enough. The relative accuracy is usually about 6 inches for these projects. As I'm going to put it on top, and I'll mention a few times, don't forget your validation checkpoints. You won't really know what your accuracy is unless you are validating it against surveyed ground control points. If you're using ground control points for your processing, your accuracy could be down to 1/10. I've seen it quite good. You do need a licensed surveyor. Some people use arrow points. Those are controversial. Discuss it within your organization, decide whether that's a yes or a no. And then ground control placement and what you're using to lay over those survey marks is really critical to your success. We're not going to go into that in great detail. There are a couple of white papers on Pix4D's sites and other sites that describe that ground control best layout. Definitely look those up. PPK and RTK, added equipment costs for the base station and the equipment that attaches to the drone, it can be another $5,000 to $8,000, so it's not cheap. But if you need that, it can be really great. You do require an internet connection to connect to MinCores. Accuracy can get quite a bit better again. The data is collected in world coordinates again, so you're going to have ground control to get that into state and local coordinates. But it can be really, really useful. PPK is kind of the hot thing right now, unless you're an ag, but lots of options there. So, and I have had some clients that just do a reference to a map with a known accuracy. If you have rather current aerial maps, manned aircraft aerial maps, those can be useful as well. So things, again, that affect it, as I mentioned previously, the weather, applicable laws, setup, and then what's on the ground. Okay, let's go into some flight planning. All right, so the first thing is you need to pick out a flight app. And why? Because if you want that overlap that we discussed at the very beginning, you need to use something that will get you your little eggs, these little red dots, in a very precise manner. So sometimes cranes can give us some interference. So the model at the top where it says manual, we flew that by hand. We didn't use an automated app because the crane was causing some problems. So we just hand flew it. And one of our chief pilots flew that, and she was really good, and that's the best she could do. The one on the bottom with those very regularly spaced dots, it was the automated map. So you can see clearly why we choose to go with the automated app. So there are a number of options. DJI has their own Ground Station Pro. It requires an iPad. You cannot run it on an iPhone or a Crystal Sky, so make sure you've got an iPad. Pix4D is good if you're using their software. Some people really love it. I think it's okay. You can give it a try and see what you think. Map Pilots, also very interesting. It has terrain following, which is super useful. There is a fee to that one. These other ones are free. I think it was like $60 per device. Litchi's another one. It's on the Crystal Sky, which is nice if you like to fly with the Crystal Sky, or it's on Apple and Android. It is very manual, but it's also a bit more flexible. So there are other options. DJI Pilot now has a mapping section. There's a number of other apps. I'm not promoting any single one here. So definitely ask people in your industry what they're using, and a lot of these are free, so it's worth checking them out to see. So here's just a screenshot showing Litchi versus Pix4D. So Litchi is great if you want to do multiple waypoints with specific actions at each waypoint. Litchi is your way to go. Pix4D, of course, then integrates directly with their software, so that's a great option as well. So let's plan a mission. So here in this red box is what we are looking at for our mission area. This is just an example. So let's say we want to get a 2D or 3D map of what's in that red box. So the first thing we want to do is discuss what our options are. So we have to decide what we want our resolution to be, our ground sampling distance. Based on that, we will come up with an overlap necessary. So that's front to back and left to right. And that overlap will be based on what is underneath us, so how homogeneous it is, and also what our AGL, that's above ground level, what our altitude limitations are. Batteries are another one. You don't necessarily want to trust DJI to send your drone home when it gets low on batteries. Most of the flight apps have that capability. It's great when the weather's great. But in the winter, that's something that you really want to consider. And if you are using it, which is fine if you want to use the automated return to home, still don't trust it. Monitor your battery levels, and if you need to come back early, come back early. Also check what your minimum battery percentage your return to home is. You can change that, 25 to 35, whatever you feel comfortable with. I would recommend having it above 30% in the winter. Just so you don't get back down to those critical battery levels. And then also make sure you note what your finish completion is, if it's a return to home, if it's a land at the end point or hover. We'll talk about that more in a bit. So let's step through those options. So we took that red block area and we sketched it out on this. This is actually DJI ground station, and it automatically, based on our resolution here, it requested at 1 centimeters per pixel. It gives me the altitude that we have to fly at for this specific camera, and this is a Mavic Pro. It tells me that what my flight time is going to be and how many photos, as well as a number of other options here. So essentially plans it out. So say I want to go from that 1.8 centimeters down to 1 centimeter. It drops me from about 200 feet down to about 100 feet. It also changes my time from about 5 minutes to 16 minutes. I had about 100 photos and now it's 358. So you can see changing your altitude significantly, changing your resolution, which changes your altitude, significantly changes your time in the air. So knowing what the right altitude and resolution is will really be beneficial to your bottom line. So here's a couple of screenshots of our options here. So we're going to stick with the 100 feet, 1 centimeter per pixel. It gives us, again, the same information, 16 minutes. It tells us our coverage area, how many batteries we need, and then here's where we set, on the advanced tab, we set our overlap. So you can set that overlap to whatever you want it to be. Again, if things are homogeneous below you or you're flying very low, you want to have a higher overlap, and that is because you need more information per photo to match the photo next to it. So the more overlap you have, the more chances for a match between pixels between those photos. So it's really important. I typically do most of my maps in 80-80. If I'm flying low or over homogeneous things, I might do 95-95. Again, that'll slow you down a lot, but it's necessary if you want to get a good product at the end. And then, as I mentioned, always know what your end of mission action is. You can choose whatever you want: hover, return to home, land. Just know what it's supposed to do. If you're going to have a problem with the drone doing something naughty, it's probably going to be at the end of your route. So just make sure, if the drone's supposed to return to home and it starts to land, you know you got a problem. So make sure you know what that is on that. All right, so it automatically creates this lawnmower pattern. It gives me a start symbol where it's going to start. I want to make sure that my area of interest is in between these overlapping lines. So this is going to fly this lawnmower pedal. It'll start at the S and it'll come up this way, it'll turn and come back this way. So we want to make sure that our area of interest is between the green lines. And the reason is you won't get any overlapping photos outside of that green line, even though it's in your area that's boxed with the blue. So you want to keep your area of interest between your overlapping lines. That might mean you need to fly more than your area of interest, but that is what will give you the necessary product to the edges of your map. So I kind of talked about this with the overlap. You want higher overlap. The overlap impacts your ability to match pixels. So things like corn, homogeneous crops, altitude. I mentioned the coverage per photo. Those will impact what you want for overlap. Both of those things, if it's lower altitude or it's a homogeneous landscape, you want to increase your overlap. Water, it's nearly impossible to match pixels of water because water is constantly moving. So typically you won't get any data over water that's not connected to a photo that has land on it, if that makes sense. So don't plan to map water generally. There are some workarounds kind of for that, but generally don't plan to map water. 60-40 is generally the minimum overlap, but as I mentioned, 80-80 is good for corridors and most models. Higher than that if you're looking at a homogeneous area. So I mentioned the laws, the rules might impact how you fly your route. And one of those is we can't fly over moving cars. And we can't fly over people that aren't under structures. So there are a couple of ways if you have to map over a roadway to look at it. So if I'm mapping these intersections down here, I might choose, in this highway has a lot of traffic that I can't get around, I might choose to straddle this. So I will map on this side and then I will hop over and map on the right side. That will limit my overlap along the center when I try to stitch the two flight plans together, but I'm not going to break the law. So if I need to get more overlap over these areas, I will increase my altitude, which will increase the coverage per photo. And for this project, it actually worked just fine. Note that you will be crossing traffic here. There is a pause button on most of these apps. You can watch through your visual observer, who should be stationed at the intersection, and also through your first-person view screen. As a drone flies up to the intersection, you can pause it, wait for a good time to go, and then resume and cross the street. So lots of good ways to get around that. In this case, I was high enough and the road was narrow enough that I could make sure no one's coming through the tunnel, cross that tiny portion right there, and then essentially just fly along the shoulder. I would have to cross one more time at the bottom, but it really limits the number of times I have to cross the street. If I had changed my lawnmower pattern to go the opposite direction, I'd be crossing the street a number of times. So keep in mind you can change the direction of these lines. So if you need to make a 3D model, when you are taking pictures for a 2D model and general mapping, you will take only nadir images, so straight down looking at the ground. If you want to make it 3D, you really want to add some oblique images. So whether that's flying the whole mission with your camera at a 30-degree angle, or coming down and doing some manual photos or some circular automated shots are really important. A couple of things to keep in mind with oblique images: never include the sky. The sky is kind of like water. It often changes, particularly if there's clouds, and it makes it really difficult to map. It's also often very sunny if there's no clouds, and that also is difficult to map. You still must have significant overlap, 50% or greater, to get these photos to mesh together correctly. I recommend flying moon-shaped or like C-shaped or circle, if you have enough space, patterns at a number of altitudes. So you want to go maybe to 100 feet, 150 and 200 feet. And then as you change those altitudes, try not to increase your gimbal angle by more than 15%. So if you find that you're changing altitude and you're so close to the object that you need to change your gimbal by more than 15%, then you're too close. And then I'll talk a bit more about the 2-second timer at the end here, but that's a great way to get these images manually. And this is an example. So in this case, I was mapping these intersections, and I wanted to get a little bit of what was underneath this bridge. So I used my lawnmower pattern that we talked about before, and then I also manually took photos. Again, so this would be, my drone would be out in this area, and I'd be flying these C-shaped patterns here. You can kind of see it, C, C, and as I go backwards and up, manually taking photos with my gimbal pointed at an angle to capture some of that area underneath the bridge. This is another example of the top down. So I was getting this, actually a big, it's Mount Josephine. So there's this green area right here is actually there's steep rock walls. So I did my top down shot, and then I combined it with quite a bit of photos here. So you can see probably hundreds of pictures. I then dropped in that area when there were no cars and took tons and tons of photos of that rock face to get my image. So here's an example. So here I did my map, my lawnmowers on the top, and then I brought the drone down along the sides, and this was actually a hospital complex, and took photos along the sides in my C shapes at various altitudes and locations to get my definition on the sides. And you can see underneath there's quite a few of these, and because of not being able to fly over cars or people, I would have to do a section, move, relocate, launch, and do it again. So they're going all the way around this area, quite a few of those shots. When you're looking at laying out your site, it's important to think about where you're going to launch. So for example, on this intersection, there was a parking lot right here, so I could park my car, have my gear there, easily accessible, just drag it across over onto this grassy area, and then launch from here. I know where I want my visual observer to be, probably on the intersection where I can't see as well. Know my pause plan, so if I'm starting, for instance, at this area, I'm going to come across here, plan to pause, be ready with that button. My visual observer on this corner can then help me understand when it's safe to go. And then also, when you're looking at site layouts, you might get to a site or have a site that you're planning, and you just decide, that's not going to be safe. I'm not going to fly that site. So you need to know when to say no as well. As the pilot in command, you have full responsibility for that flight from pre-planning to recovery. So even if somebody else is planning your flights, if they don't plan it safely and you go anyways, it's on you. So as the remote pilot in command, it's your responsibility to say no when something's not safe or not smart. Be aware of wildlife. So these birds are crazy. I was doing some post-processing inspections on this one on the top, and I saw this big flock of blackbirds that I flew over. I was doing some work out of Allianz, and we had a seagull that kept getting in our pictures. Hawks are a big one, eagles. Be respectful of birds, and then if you see one, just land. You can usually wait them out. And then, of course, if you are in the air, just be cognizant of where they are and that you will not be in their way. So a few things when you're setting up your site to know some emergency settings. So you want, and these are in the menu. If I'm assuming DJI for all these, since that is what's most common with our public agencies and industry folks in the state. If you have other aircraft, there are similar settings on your aircraft in many cases, but again, these are going to be DJI. So in your main menu, you have a return to home. You want to know where your return to home is. Is it at your current altitude? Is it at a predefined altitude? Understand what these settings are and where they're located. So here we have selected at the current altitude. We also have a return to home altitude set. And so I have 50 feet here. So you need to know if a building's in your way, if you're in your lot of trees that are 75 feet tall. Don't put your return to home, oh, this is meters. Okay, good. Don't put your return to home at 50 feet if you've got 70-foot trees in your area. I also highly recommend setting your max flight altitude. 120 meters, and for some reason DJI has this really weird mix of meters and feet, and some you can change and some you can't. But 120 meters is about 393 feet. And I recommend setting that because if something goes wrong, the drone won't cross that. And that's really important because it's one of the FAA rules. And also because we can't go above 400 feet because manned aircraft typically fly at 500 feet and below. So you are much safer, and the world is much safer if you set that max flight altitude before you go anywhere. There are a number of camera settings that you want to get familiar with. Definitely, so if you're shooting photography and videography, you might shoot in 4:3, you might shoot in 3:2, depending on what you want your end products to look like. But when you are mapping, you want to make sure you shoot full frame. And because why not? These different sensors all have different ratios, different native ratios. So make sure, take a screenshot of this or write it down in your own manuals or your own cheat sheets so you don't forget which aircraft have which ratios. So in this case, in your camera settings, you can set that image size ratio. So there's my 3:2. You want JPEGs for these. Most of this software will only take JPEGs, not RAW. And so that's in settings. For the majority of the sensors, particularly the P4 and the X4, which are very common with mapping projects, you want to go to manual focus and set your sensor to infinity focus. That gives you the best focus for these high aerial. And then you also want to make sure a manual for your camera settings. So I have found that I don't want to go above ISO 100 typically. My shutter, so I'm inside, there's my kitchen. Typically you don't want a shutter speed of less than 320. I usually keep my f-stop between 5 and 5.6, and these are my personal favorites. So it's important that you go out and do a couple of trials, especially with your specific equipment, particularly if you're not using a Phantom 4 or an X4S sensor. Figure out what works for you. Process a couple of these on some test sites and know what's best for your sensor and your application. Fly to your altitude that you're going to be taking your photos at. Turn your sensor straight down, just like it will be doing when it takes photos, and get used to your histogram. So this is the blacks and whites in your photo, and you want this bell curve to be mostly centered, and that's how you so the thing you should be adjusting here is your shutter speed. So you want that bell curve right in the middle. So you fly to your altitude, adjust your shutter, and you'll be cool. So let's talk about flight operations. As I mentioned, I haven't mentioned that yet, but you need to know your start and your end point. So when you plan these, you have the ability to change your flight angles and know where you're starting and where you're ending. So if I'm launching from this arrow here, I'm comfortable starting far away because my end is going to be near me and I can easily recover and fly home if I'm low on batteries, if the drone does something squirrely, etc. So I feel comfortable with that. Sometimes I might want to take off nearer me if I have a long flight path and I'm not totally sure I can keep it within line of sight. I want to start here and start mapping, and if I find I get partway through my leg and it's getting beyond line of sight, I can stop and return to home. So lots of different considerations for that. As I mentioned, review your end of mission action, whether it's hover, return to home, or land. Know your wind direction. That's important for battery management. If your wind is going to be coming at you on the last leg, and then you have to fly it all the way home from a far point, you want to keep that in mind. So we haven't talked about LANCE yet, the altitude or the airspace system, but you also want to think about DJI Fly Safe. So in addition to LANCE, DJI also has its own manufacturer's restrictions, and those will impact your ability to take off and land unless you get pre-authorization or field authorization. And you can find more about that on DJI's Fly Safe website. So just a couple of troubleshooting notes. You might want to come back to this or write some of these down because they're bound to happen to you. When I'm testing out my camera settings, I'm usually doing that in DJI Go 4, and then I have to switch back to Ground Station Pro to actually run the mission. Sometimes it won't recognize the drone, and the best way to fix that is just to reseat the cable. So unplug it and plug it back in. It's best to do that when you're on the ground, just because you don't want something to go wrong in the air. So I usually go to Go 4, do my camera settings, come back, land. If I can't switch to GS Pro easily, then I reset the cable. Once the drone's ready, I can then take off and start my mission. Interesting thing that I found with these drones, particularly with the P4, is that if it's windy, it doesn't seem to give it full power on takeoff. I have a couple of times had the drone tip over on takeoff when it's been windy when I'm in automated mode. So sometimes if it's windy, I will launch manually, either with my hands or off the ground, give it full power, and then once I'm in the air at a safe altitude, I'll then initiate the auto flight. The next one's super, super important. I should have highlighted it. No ADI mode or sport mode. Depending on your aircraft, the Mavics are sport modes and the others are ADI mode. That is your best friend. If you are flying a mission and you need to stop right away and recover the aircraft, you can either hit the pause button or you can switch to ADI mode. ADI mode kicks it out of GPS, kicks it out of your automated route. It will immediately stop your aircraft. It pulls it out of GPS mode, so if you're having a flyaway that's induced by GPS, it will recover it. It won't recover the aircraft, but it'll recover the flyaway. You can try kicking it back into GPS mode and see if it's recoverable, and that'll be the case if you're stopping your flight, or fly it back in ADI mode if necessary. It's super important to be comfortable with ADI mode. In ADI mode, you don't have GPS support, so it'll fly really squirrely. If you're going to try it out, you should try it out. Make sure you've got some space to see what happens, but it's really, really important that you get used to ADI mode. Another thing that I learned the hard way, DJI names the photos in rounds of 999. So when you go to fetch your photos, if you've got more than 1,000, you'll see that they're in a couple of different folders. Be sure to rename them something unique, because DJI 0001 is the same as DJI 0001 in the next folder. So if you don't have them renamed and you try to use those photos in the same model, it won't work because they'll be essentially in the same thing. So definitely name your photos if you are rounding that 999. All right, so let's go. Let's fly our drone. So when I'm in my mission mode, I've planned my flight and I'm ready to fly. I hit the little blue airplane symbol up the top right, and the drone will go through a number of checks to make sure that it's ready to go. In this GPS area, if there's any no-fly zones or unlocks requirements, it'll tell you that there. So that's a good place to check. I was testing it, didn't have an SD card in this one apparently. But then when it's ready, it will give you the start to fly. So then you fly the route. This is the part that I always laugh. It's fun to fly drones, except when you've got a full day of just staring at the sky. So bring a cup of coffee, bring your favorite jams, keep an eye on the drone. Of course, don't look away from it, but it's a whole lot of looking at the sky. Invest in some good sunglasses. You will be grateful. It's very important to take care of yourself. All right, so as the drone flies, and this again is in Ground Station Pro, but a lot of the software, Pix4D, Field Agent, etc. are the same. As the drone flies, it will take pictures, and as it takes pictures, most software programs will lay an egg. So, and Ground Station Pro also does a little camera clicking noise. Monitor the egg drop and the sound for consistency. There's a little bit of delay, it's not exactly right, but if you hear a long delay or your camera stops clicking, I've had a number of times with DJI updates that it doesn't take pictures for some reason. I have to update something else, or there's the update didn't go well and it's not working. Make sure that you're getting those eggs dropped, those pictures taken, so you don't fly a whole route, come back and find there's no photos. Also, most of the software has a symbol that indicates the direction of the flight. If you have an emergency, you want to know exactly which way that drone was facing. So note that direction. Sometimes the drone can fly backwards, so your arrow pointed the other way, and you want to know that just in case something happens. In the bottom corner, there will also be an FPV view from the camera on your drone. You can tap on that and it will switch over to that. So that's really great for monitoring your operations over people or moving cars. And again, the pause button's up at the top right. Be comfortable using that pause button when necessary. So here it is in real life. That's the side of my unpainted house. So here's your first person view over, oh, actually I clicked on it. So your first person view is now the main screen and my map is now the small screen. I have access to my camera controls. This is really great for not flying over stuff. It's interesting, it has all the camera settings up here and you can adjust those, but only when it's in between waypoints. So I can't adjust my camera settings along the way that it's taking photos, but when it stops to turn to the next leg, I can change my camera settings during this portion. I don't know if that's the same for all the apps, but that's how it works for Ground Station. All right, so when your mission is complete, again, maintain situational awareness, know where your aircraft is coming from. On DJI, I have no idea why, but it takes away all of your flight stats, so your altitude, your speed, your distance, etc. will all be gone. So you can over here, you can pan, so here it is. Literally, you're flying the drone and it gets back to the home screen. So it does have your drone and it has your home point. So you just need to know, this is why it's important to have visual line of sight, because you need to be able to get the drone back home and DJI is not telling you what its altitude is or how far away it is. So you can move this screen around to find your drone if you have a longer model. But you do want to maintain good situational awareness. All right, over to processing. And I'm going to go through this quickly because there's a number of different software products that you can use. The basic elements are the same. This is Pix4D, but there are a number of different products you can use. Basically, as I mentioned, it takes all these photos, it looks at the differences between the overlapping photos, usually in pixel color and geometry, and stitches them together, to put it easily. And then those are called the tie points. And then it comes up with all these XYZ points in space that it's tied together, and it creates a point cloud. So this is not an ortho mosaic, it's actually a 3D point cloud with my ground control points noted here. So these are all just XYZ points in space. And then that can be turned into your ortho mosaic. So here is an actual TIFF of the area that we flew for this project, for this test project, over by the U. Then I can do things like add contours. This one I was actually overlaying with a near-infrared model, so I had some tie points to my different models because the resolution of the cameras is different, but all kinds of great things that you can then get from these models. So quality analysis, you can go super basic, you can go super complex, depending on what you're using this for. Simple things like how many matches did I have between the photos are visible in the Pix4D products quality reports. So as I mentioned, water doesn't model very well. You can see there's not many matches here over the water. It's easy to tell where you might have there. At the edges of your maps or in some areas with low overlap, you might have some visual anomalies. You can easily fix in post-processing. It does impact your accuracy, so understand how you're manipulating your model on the back end, because that can impact your accuracy when you're done with all of your. Again, quality checks are important. So when I'm looking at this area, I see some strange, marshmallows on this road. This is supposed to be the terrain model. That looks weird. Are the potholes? What is it? And look, and it's actually cars. So the model didn't pull out those cars as it should. I can select those and delete them. This is so so there's some folks have concerns about privacy. I don't want to be modeling people. Know that you can do some editing in the point clouds. It does take work, so within reason, this is something that you might want to think about long. Okay, so I always say, but wait, there are rules to this, and the reason is drones are aircraft. Oh, look, there's no title on this slide. Drones are aircraft, and aircraft are regulated, and regulatory compliance takes a lot of effort. There are 3 layers. There's the federal, state, and local ordinances. One thing I like to show over on the right-hand side is this map of Minnesota. All those yellow circles, it's actually the metro area, those yellow circles are the airports or landing areas for airplanes. Those are a lot of them. Most people think if I'm not in the metro area, I'm not near aircraft. That's not necessarily the case. So to protect those aircraft and the people aboard them, we have federal, state, and local ordinances. So they're referenced there. You don't need to look at the MNDoT one there, but federal, state, and local ordinances are required. So for the FAA, there are basically 3 things that you need to have to be an unmanned aircraft pilot. The first thing is you need your remote pilot certificate. So here's an example of it. That's a 60-question test over 2 hours, worth studying for. The pass rate's pretty good. There's a lot of good material out there for it. You need to register your aircraft with the FAA, and then you need to follow the rules. And those are things like staying below 400 feet generally. Your aircraft has to be below 55 pounds. You have to stay within visual line of sight of your aircraft, and that means the pilot, not the visual observer. The person who's manipulating the controls has to have line of sight of the aircraft. You cannot fly over people. You have to fly in good weather, and that's defined as 3 miles visibility with a couple of other things. You have to have approval to fly in controlled airspace. So that's like St. Paul, Minneapolis Airport, Anoka County, Anoka Airport, Flying Cloud Airport, Bemidji, etc. There are also special requirements for flying at night. And the interesting thing about the FAA rules is that they have been changing. There have been some recent changes to recreational flyer requirements and also airspace authorizations. There are changes coming soon, maybe possibly this summer, about flying at night over people and over vehicles. We expect some changes coming in the future about remote ID. So that's essentially a license plate in the sky. Also beyond visual line of sight changes coming in the later future. And then lots of other emerging topics such as package delivery and unmanned aerial vehicles and how that flows into here. So it is a bit of work to keep up on the federal rules and requirements, and it's important that you keep up on them because they are the rules. As I mentioned, big sky, little plane, we have about 400 places that airplanes land here in Minnesota, quite a bit. So we don't want to hit those. Going on the Minnesota State Statutes, MNDoT is a state-level aviation regulator. There are some state statute requirements. They include getting a commercial operations license if you're operating drones commercially. Commercial operators also have to register their aircraft and pay sales tax, and then they're required to have aircraft liability insurance. I am one of the UAS representatives at MNDoT, so you're welcome to give me a call. We also do things like monitor local ordinances, and there's a link to those. I'll have some information on that in the next slide. And then try to host education outreach events like this, and also Minnesota Drone Day, which unfortunately due to COVID is not going to happen this year, but other outreach events as well. There are a number of local ordinances. You can look these up on MNDOT's site. They are also available at the owner's site, St. Bonnie, Arlington, Eagan. There's a number of other ones. These are hard to find. Not all of them are in accordance with the federal rules and regulations, but we all have to, you should adhere to them or talk to somebody who owns them. If you hear of new ordinances, please let us know here at MNDoT. We're trying to keep a list of them. We also provide support to local governments that are considering adding UAS ordinances. There may be some benefits to some communities, and we want to make sure that we support them in writing ordinances that make sense for the community and the aviation community. There are some NOTAMs. So NOTAMs are notices to airmen. They are messages put out to airmen from the FAA, and one of them is critical infrastructure. We are strongly advised, to the extent practicable, to avoid flying near critical infrastructure in sensitive locations. So there are a number of things listed there as to what those are. And to stay away means 3,000 feet laterally and 1,000 feet above. So power lines, emergency services, government facilities, nuclear reactors, transportation systems, etc. Do not hang out there if you're not supposed to be there. So please be cognizant of what you're flying near. So the next thing to talk about is LANCE. LANCE is the aviation UAS air traffic control, essentially. So it's administered by the FAA, but the front end is run by commercial companies. The FAA manages all controlled airspace, and they have predefined areas that drones can fly in. So when you're flying around airports that have control towers for manned aircraft, they have designated altitudes where they think drones will be safe to fly to without their direct conversations like you would with a manned aircraft. So for example, if we're looking at this area, south of Fergus Falls, they might say right near the airport, there's no safe altitude for drones, so 0 feet. Out here a little ways, you can go up to 100 feet, and as you get farther away, you can go up to 200 feet. And those are automated approvals. If you need to fly at 200 feet in the 100-foot grid, there are ways to request that, and it just takes a little bit of paperwork. These maps are available at faa.maps.arcgis.com. Keep in mind that these grids do change, and I have frequently, rarely, or never. So those are all the case. The metro area just had a change a couple weeks ago that was very beneficial, but it hadn't changed for a year or so before that. So generally, the FAA's rhythm is a 45-day review. But it could be more, could be less, depending on what's happening in their airspace. So before you fly, even if you're used to always having a certain altitude, make sure that you check. So how does this work? The FAA air traffic control comes up with these grids. They also have things like TFRs, and those are for things like fires, VIP movements, special events, security events, etc. They add in things like NOTAMs, notices to airmen, and then these facility maps, which are these grids, and then a service supplier, so front-end company like Air Maps, Skyward, Kitty Hawk, etc. have apps that tie in all of that data and then provide it to the drone user. So you can get this information from one of they're called UAS service suppliers, and there's a list of them on the FAA site. So I encourage you to go out and find an app that you like. I'm not going to go into this a whole lot. If you have questions about this, you can give me a call. It can be a little complex. If you're flying, again, in any controlled airspace, you have to request authorization, even if you're flying under the altitude that it notes. And sometimes it might take a little extra work. So, just a note, you can see here typical traffic patterns into and out of an airport. They're somewhat standard on the smaller airports. They can be a lot more complex than the larger airports. But understanding how airplanes approach and depart from these airports is really important. I highly encourage people, if you're going to be flying around an airport consistently, it's worth going and getting an hour of ground or an hour of flight training from a certified flight instructor at that airport. It'll really help you understand how those operations are. So if you do need to operate closer to the airport, you have some knowledge about what's happening there. It's not just for controlled airports. There's also some protection of outlying areas within that airspace. So for example, St. Paul Airport quote, owns all of this airspace in here. And so you would expect near the airport, you don't have very much altitude. As you go out, you can get higher, But then we see this 0 grid out here, means there's no safe altitude for drones. And you might wonder what that is, and you find here there's an uncontrolled airport in that area. So keep an eye out for surrounding helipads, airports, emergency services, etc. When you're looking at your. I mentioned DJI Unlock. This is another one that's worth looking into on your own. It's the manufacturer's safeguard to keep you from entering airspace near airports or other restricted areas like jails. It's a lot. There's a lot more of these than there are controlled airspace. It is not necessarily related to LANCs. So look at these in advance and figure out how to use it because it's important. The next two slides, we're a bit out of time here, so I'm going to kind of skim through them. You can, again, look these up on DJI's site for more information. There's a self-unlock that you can do yourself on site. And there's also a custom unlock. So when you're closer into the near inner airport areas, it will require more information from you to get access to those areas. Okay, some apps that'll be interesting to you. Weather. Weather is a very important app. Weather.com is just your average weather app. It's good because it has wind predictions on there, hourly temperatures, precipitation, etc. I really like AeroWeather. There's a free version where you can get your METARs and TAFs. When you take your 107, this stuff, all these things right here, is what you'll need to know. You'll need to know how to decode that. And they can get complex if you're not familiar with weather. The neat thing about AeroWeather is that you can then tap on decoded versus raw, and it spits it all out in people speak. So it's a good way to practice for your test, but it's also a really good way to get airport information. So this is available for all the airports that have weather, and there are a lot in Minnesota. We've got a really good weather system. So I highly recommend AeroWeather. Dark Sky is another one that's kind of popular. That's a paid app. And there's quite a few out there besides that. So take a look. Again, I mentioned flight apps. So we covered this in the beginning. There's a lot of options for you, depending on what you're using the app. As far as the LANC apps go, there's also a number of options of those. These get quite complex. Before You Fly is one run by the FAA. You can't actually request access to airspace on there, but it'll give you information about the airspace that you are flying in. AirMap, Skyward, Kitty Hawk, etc. Some of them have web-based request options. Some of them have apps. Try them out, see which ones you like. Some are paid, some are free. There's a lot of good options for you. And I wanted to mention here just at the very end, one alternative to mapping. So it's important to know what you need for accuracy. If you're using your drones for inspection-related tasks, sometimes an alternative is a bit better, and that's the 2-second timer in your drone. So it's essentially a stitched-together photo in the loosest terms. There's not an accuracy attached to it. It's good for inspections, documentation, site overview, etc. It's super easy. It is tough with tall things. Even when you're processing 2D orthomosaics in Pix4D or Info or what's the other one? I forgot. When you're processing those in the photogrammetry software, it still processes in X, Y, and Z. When you're stitching things together in Lightroom, it doesn't. So when you have tall things, there will be warping that occur depending on your altitude versus the structure height. You also want to keep it small based on your processing power of your computer. It does take quite a bit of computer power to get through these. I find less than 30 photos is good. And you don't need very high overlap in order for this to work. It's something that you can easily try this yourself at home. So what you do here, you go to your, oops, these got shifted. You go to your camera settings, this button here. In your photo options, you click on time shot, and you can click 2 seconds, 3, whatever you want your timer to be. I like 2 seconds. It gives me a good overlap with my flight speed. And then I click the photo button and I fly. And as I fly, it takes photos every 2 seconds, and you can see how those buildings change over time. This is what I mean about the building height. So here, when the drone or when the software tries to stitch this versus this, where you can see the edge of the building, and then here even more, it'll have some trouble and create some warping there. So a higher altitude gives you lower view of those oblique areas, just something to keep in mind. So anyway, you get a bunch of those and then you stitch them together and you get this large sight view. Again, these are not accurate in terms of measuring, but they are really great for inspection, stock counts, project management, etc. And they're very easy and very quick to do. So I highly recommend taking a look at them. Here's another example of some stitched together. Another great option is at night. So in this case, it's sometimes difficult for some of the software to stitch night photos because, again, it's quite homogeneous. It's just there's just not much differentiation when it's black. There's not much to match there. But Lightroom has an easier time of stitching these together. So I can get a good analysis of, or a good view of things in the dark if I don't need to measure. All right, so here at the end here, there's a number of free resources for you. I'm happy to answer any questions you have about this PowerPoint or about the MNDoT statutes over at Aeronautics. There's my information there. Al is our local FAA representative over at MSP. You can contact him if you have any questions. The MNDoT Photogrammetric office was over at OLM, was one of the early adopters for drones. They're super busy, but I'm sure they'd be willing to answer some questions if you've got them. I would also recommend contacting your local government and your law enforcement in your area. A lot of police departments and cities now fly drones. So if you have questions about ordinances, they might be able to help you if you have questions about restrictions, etc. And then, of course, organizations like MNGIS can be a great resource for you. So with that, I'll close it out. Again, please contact me if you have any questions. I'm happy to help, and hopefully we'll see you all next year.